Hello, and welcome to this video on factoring the difference of two squares. When factoring polynomials, there are a few special patterns that you'll want to be on the lookout for. The one we'll be talking about in this video is the difference of two squares. When you see a binomial in the form a squared minus b squared, then you know that you're looking at a difference of two squares, and it will factor to a plus b times a minus b. The reason there's no middle term is because foiling out these binomials will result in the outer and inner terms canceling each other out. So if we look right here, we'll have a times a is a squared, and then a times negative b is minus ab, b times a is plus ab, and b times negative b is minus b squared. So our middle terms cancel each other out because we have a plus ab and a minus ab, and we're left with a squared minus b squared. So that's why it factors out like this. So let's look at a few examples. X squared minus 4. We know that this is an example of a difference of two squares because it is a binomial with a subtraction sign between the two terms, and both terms are perfect squares. To factor this binomial, take the square root of both terms, ignoring the minus sign. So the square root of x squared is x, and we're going to take the positive square root for each of these. And then the square root of 4 is equal to 2. Remember, a difference of squares binomial factors to a plus b times a minus b, and in this case, x is equal to a and 2 is equal to b. So it's going to factor to x plus 2 times x minus 2. If you wanted to check your answer, you can always FOIL it and see if you get the original expression. Let's try another example. X squared minus 36. First, check that this matches the a squared minus b squared pattern. It does, so take the square root of both terms. So the positive square root of x squared is x, and the positive square root of 36 is 6. So now we're going to write out the factored form of our binomial. So we'll have x plus 6 times x minus 6. Let's try one that's slightly harder. 4y squared minus 16. First, check that it matches the a squared minus b squared pattern. It looks different from our other examples, but this does follow this pattern because 4y squared is a perfect square. So we're going to take the square root of both terms. So a is going to be equal to the positive square root of 4y squared, which is 2y. Now we know that 2y is the positive square root of 4y squared because we're going to take the square root of our coefficient 4, the square root of 4 is 2, and then multiply it by the square root of y squared, which is y. So that's how we simplified this. Then we're going to do b and take the square root of 16. The positive square root of 16 is 4. So now we have our a and b values, and we can write out our factored form as 2y plus 4 times 2y minus 4. Before we go, let's work through one more example. 16 a to the 4th minus 49. First, make sure it follows the pattern a squared minus b squared. Since it does, take the positive square root of both terms. So our a is going to be equal to the positive square root of 16a to the 4th. So remember to take the square root of an expression like this, take the square root of the coefficient first. The square root of 16 is 4. And then the square root of a to the 4th is a squared. So we'll have 4a squared. And then b is equal to the positive square root of 49, which is 7. Now we can write it in our factored form. So we'll have 4a squared plus 7 times 4a squared minus 7. And there you have it. Now you should be more comfortable recognizing the difference of squares problems and know how to factor them. I hope that this video was helpful. Thanks for watching and happy studying.